Welcome back, friends. Thanks for being here. Buckle up and subscribe because it's going to be fun. So this is machine number 1 on the Commodore 64 haul that we started off on a couple of weeks ago. I opened it up, I identified a couple of missing chips. We've got the VIC2 chip missing, the SID chip missing. This is a switch chip of some kind. These are two 74 series logic chips, and then another one of these 74 series logic chips here has been socketed, so there might be a little suspect that might already be repaired, or it might already be broken again. You never can tell with these kind of things. So we'll get into it. What I did was I took some time, obviously, because you haven't seen a video for a bit, and ordered all the chips that were necessary off of eBay and various other sources in order to get them, and they're here. So without further ado, let's start putting chips in. This is a known working VIC2 out of another machine, so we'll get that installed right away. Got one pin off. Alright, that one's in nice and good. And if you haven't installed a chip in a socket ever before in your life, there is usually a notch indicated on the printed circuit board, or on the socket itself you'll see a notch on one side and a flat end on the other, and that matches up with the notch on the top of the chip right there. So this is the SID chip. Put that in. That's a 6581. It is made in the 22nd week of 84, for those of you that are keeping score with those things. The 74 series logic chips, put those guys in. Straighten that one pin out just a bit. Straighten this pin out just a bit. These two 74 series logic chips actually came from different lots, so that's fun. I'm sure these are pulls from something in order to show up in different lots like that. And then finally the switching chip. And this switching chip is a CD4066BCN. Looks good, looks good. Put it in. And now the moment of truth. We've got a AV cable plugged into the back. We've got power plugged into the side. All the chips are plugged in. Let's see if it comes to life. See if it is just really that easy. And I turn it on, and there is no signal. So no, it's not that easy. Power supply is on. Double check all the sockets, make sure they're good. These ones aren't socketed, but I just feel like touching them anyway. The fuse looks pretty good. So next step is try a dead test cartridge, see if that helps out any, because at this point it couldn't hurt. Plug that guy in, turn it on, and still no video signal. We do have power on the dead test cartridge, so that's working. And this is a dead test cartridge that has two different versions of the ROM, so we'll switch over to the high version, switch it back on. Again, we have power and we have no video signal. Alright, let's do a little bit of research and see what we can come up with. Okay, so in order to test, you need some test tools. I got my handy dandy multimeter here. This one was probably about 20 bucks from Radio Shack, back when Radio Shack was a thing. It is an auto-ranging digital voltmeter. I put a link below, but Radio Shack doesn't exist anymore, so basically just find a cheap auto-ranging multimeter, or any multimeter will do for this task. I just happen to prefer an auto-ranging, and I don't really think that you need a whole lot of special equipment to do this kind of troubleshooting work. So what we have is we turn the machine on, and we get a light on the dead test cartridge that I have, and that will tell us that there's power to the cartridge port, but basically no signal on the screen, and nothing works. So we've got the VIC chip in, so there should be some kind of signal to the screen. So the next thing we need to do is test some voltages. So I'm taking the common lead or the negative lead and hooking it up to the shell on the cartridge port, which is a good known ground. And what we'll do is we'll start checking voltages around the system where we know where voltages should be. So the first thing is, let's check the 5-volt rail from the power supply. We check that by looking at the outside pins on the LED connector on the top case. We got 4.92 there. That's okay. And the connector is actually a 2-wire connector, but it's set up so that you can't plug it in wrong. So the ground is the center, and then the two outsides are both positive, and 4.92 volts on the other side of that, so that's good. Next thing to check is the voltage regulators. This is a 7805, so it's a 5-volt voltage regulator, and this is a 7812, so it's a 12-volt voltage regulator. The way these guys work is the center pin is ground, and the two outside pins, the one on the left is your source, and the one on the right is the proper voltage that you're looking for. 7812, the 12 stands for 12 volts, 7805, the 5 stands for 5 volts. So the easiest way for me to remember this is the right voltage is on the right side of the circuit here. So if we look on the left side for input voltage, we have 0.4 volts, so not a whole lot going on there. On the right side for the output voltage, we have 0 volts, nothing on the 7805. On the 7812, we'll do the same test. 0.5 volts on the input side, and check the output side, 0.128 volts on the output side. And what we're looking for on the 7812 is obviously 12 volts, so we're nowhere near that. So the next obvious thing to check is the fuse. What do we have going to the fuse? 0.3 volts on the inside of the fuse, 0.12 on the outside of the fuse. Some other common places are the user port up here in the back, where this split is in between them. You put one probe on each side. Actually, that's not the user port. This is the user port. Put one on each side, and you should get 5 volts. I've got 5 volts there. I put one on each side here, and you should have 12 volts. And I have no volts. Okay, so basically we've got no power on the 12 volt side of things. We do have some power on the directly connected 5 volts, which is directly connected to the power supply. Power supply provides 5 volts and 9 volts. The 9 volts gets converted to 12 volts and 5 volts again. I don't know why yet, but I don't know why they do 5 volts twice, but they do 5 volts twice. So there you go. Some things are 5 volts from the power supply, some things are 5 volts from the regulator. It is what it is. They had a reason for it. They know more than I do at this point. At some point in the future that might change. So, next thing that I want to check, obviously we're getting power in over the power connector, so the power supply works. Cartridge port has power, the LED has power, the user port has 5 volt power. So I want to make sure that we're getting power into the machine. So we'll start at the next step from the power input plug is the switch. And these switches are kind of interesting. From what I understand, they don't make them anymore. So finding a replacement is going to be fun. But there are 6 connections on the switch, and out of those 6 connections, these top 2 aren't connected at all. And on some of the machines, you'll actually see where they aren't soldered into the motherboard. On this one, they're soldered into the motherboard. So that leads me to believe it's already been touched once. So again, we'll hook up the ground to the cartridge port and be very careful not to connect things you shouldn't be connecting in here. We'll connect the top of the case towards the cartridge port, the farthest down and to the right connector, and that's got 4.7 volts. Should be somewhere in the 5 volt range. This machine's acting a little quirky right now, so I'm happy with 4.7 volts being there. The middle connector on the top side is the switched. So if you flip the switch, it will transfer power from pin 1 to pin 2. That's 4.6 volts. Again, that shows that there's some power there, so I'm happy with that. And then on the bottom side of the connector, the same deal. The lowest one, 13.5, 13.0, 13.1. All right, I'm happy with that. And then the one that is connected when the power supply switch is switched is the next one, the middle pin on the bottom row. And I get 0 volts there. Okay, so now we know that the problem's with the power switch. So that's pretty straightforward. So what do we do about it? Well, temporarily what we can do about it, turn the power supply off, light goes off on the card, turn the switch off. Temporarily what we can do about it is we can jump past the power switch itself. We'll technically be able to turn the machine off at that point, but it'll prove that the power switch is or is not the thing. So get a spare lead from a old resistor leg that I cut, give it a little bit of a shape. Looks like that ought to do something there. And then what we can do is jumper across. There's no exposed wires over here other than this other than these pins, so I'm not risking shorting anything out. Alright. Nice good connection there. Verify that our power supply is off. Turn this back over. Plug in the display port. Plug in the power port. Turn this switch on so that the 5 volts works the way it's supposed to. Turn the power supply on. My screen timed out. Shut itself down. Power saving is a wonderful thing. Alright, and we will turn the power supply on. And we've still got that dead test cartridge in. That lit up, and the screen is now showing that there's a signal, and the dead test is running. So this looks successful. So the next thing we need to do is take care of that switch. What I'm going to do is I'm going to search for some spare switches and see if I can order some spare switches to make a replacement there. And if not, I have a couple of other machines in this haul, and one of them may wind up being the donor for this until we can get that switch ordered. So there we go. I'll give you a quick screenshot of the dead test cartridge running, and we're good to go on this one. Thanks for watching. If you liked what you saw, click that like button down below. Got a tip jar at the bottom there if you enjoy what I do and want to help support making more content. But for now, that's it. That's a wrap on this one. We will have to dive into machine number 2 and see what we can do with machine number 2. Thanks again.